Alright guys, I'm going to show you how to install your piston rings onto the pistons, and then we're going to go ahead and put these pistons down into the cylinders, connect our connecting rods, we're going to check our bearing clearances, and then we're going to have a short block. Very, very important when you're installing pistons and rods is the orientation of the pistons. You can't just throw them in any which way. They actually matter which way they go. All pistons will have some kind of dot on them, or an arrow in this case. You can see that little arrow right there facing that way. It goes towards the front. That always goes towards the front on the piston, but check with your piston manufacturer, make sure that that's going to be the right way to go. And then also it matters which side it goes on, because if you put it in this side, then this side of the rod is going to be rubbing with the rod on the other side, so the rods will be touching this way. But if you put it on the other side of the engine, then the rod will be on this side, and it actually matters which side the rods are rubbing up against each other, because on this side you can see that little machined chamfered edge right there that was machined that way so that the rods could butt up next to each other and slide against each other. On this side there's also a chamfer, but it's bigger and it's cast. This side is going to go against the crankshaft. So if you ever forget which way it goes, these little tangs on the inside of the rod bearing, which by the way, tangs on the caps always go with tangs on the rod. They always match up like that. Those tangs always have to face on the outside of the block towards the headers, towards the oil pan rail. So if I were to flip it around this way and still put it in with the arrow facing towards the front, then I would have my rod chamfers on the inside of the block. And if you do it that way, the crankshaft will not rotate, it's going to lock up. And so if you accidentally do put one in the wrong way, it's kind of hard to actually mess this up, because when you install your pistons, if the crankshaft locks up, then you'll know that you installed one of these the wrong way. We're going to be installing these sealed powered forged aluminum hyper-eutectic pistons. The only reason why I went with these ones is because they're suitable to the horsepower needs that I'm going to be running. They're going to be okay for the RPM that I want to run this engine at, and they're super cheap pistons. To be honest, I wouldn't recommend getting these ones. I'm just reusing the ones from my last engine build. They're the 4 eyebrow pistons. You can tell that these are used. They've just been cleaned up. They're still in great shape, so I still would really like to use them. So if you are going to buy new pistons and rods for your engine build, check with your machine shop and see what they recommend you getting, because it's totally specific to your application. You can get lighter pistons so that you can rev it a little bit higher. You can get stronger rods. One cool thing that you can do with pistons and rods is buy a longer rod. This is 5.7 inches. You can get a longer rod like 6 inches and then a shorter piston, so you don't have to change anything with the block. But basically what that does is it gives you a longer dwell time. When the piston gets to the top, that transition area right there where the rod is coming over the top, there's more dwell time at the top of the piston. And then when the piston comes back down, it's going to accelerate a lot quicker with that longer rod, because it's already, halfway down once it starts pulling the piston, and then it's going to start coming back up. So you're increasing your dwell time, accelerating the speed of the piston, and you're going to create more power that way. These ones are going to be good for the build that I'm going with. I decided not to spend an extra $2,000 just on some rods and pistons when mine were still in good shape. I'm still going to be able to rev this engine to 6,500, 7,000 every once in a while, depending on who I'm racing. And these are going to be fine for what I'm trying to do with the horsepower range that I'm going to get. And their forged pistons are going to be strong. The hyper-eutectic basically means that they have a little bit more silicone in them, and the silicone reduces thermal expansion, and so it allows you to run a tighter clearance in your cylinders to your pistons, because it's not going to expand so much. You don't have to have such a small piston, so that reduces piston slap. And then these pistons are also coated. They have these little this coating on the skirts here, and that's to help reduce noise and piston slap as well. And then these rods are plenty strong. They're the powdered metal rods made from GM. They came in the LT4s, some of the Corvettes. Super, super strong rods. They're not great for super high RPM, especially with a heavier piston. But if you got lighter pistons, these rods would carry you to a high RPM. The crankshaft is pretty much bulletproof for any build that you're going to do. This is just a stock crankshaft. You can buy an Eagle or a Scat crankshaft that are forged, but unless you're running high amounts of boost or lots of nitrous, I honestly don't think it's necessary. These crankshafts are bulletproof. I've seen people run close to 1,000 horsepower on a stock crankshaft, revving close to 7,000, 8,000, 9,000 RPM sometimes, as long as they have a correct connecting rod and a piston setup, then it should be totally fine. So this is just kind of the setup that I'm going with, but check with your machine shop and see what they recommend you doing for the build that you want and for the horsepower goals, and what kind of driving you're going to be doing. All right, so after installing a couple of these rods, I got a little system down to kind of make things go a little bit smoother, a little bit faster. The first one's always the hardest because you're just like trying to find where all your tools are and trying to get everything set up and trying to get a system down. But I'll show you the system that I found to make it easiest to go in a smooth, nice paced order. And you can kind of copy the system for yourself. So I've just been starting by cleaning everything very first. First, I'm going to clean the bottom of the engine while I'm down here. I'm going to start by cleaning this whole journal, and I'm going to clean this journal, and then I'm going to install both of the pistons onto this journal right away so it doesn't have any time to collect any dust or anything. It's already pretty clean, but I'm just going to give it a quick wipe. I have a towel sitting with my brake clean, a towel sitting with my WD-40. I'm going to be using both of those, and so let's do the brake clean and clean off this bearing first. Make sure you get a flashlight while you're doing this too so you can see very clearly what's going on. One thing you want to be careful with microfibers is the microfibers will catch on the edge of these holes here and you can end up getting some fibers in there. Just want to make sure, be real careful, look very closely at everything you do. Pay extremely close attention to everything. And like I said, make sure you have a flashlight so you can see everything. Brake cleaner is great because it dries so quick. And it's not going to leave any kind of residue behind. Alright, now that pin could not get any cleaner. I've gone around the whole thing. I've looked at everything thoroughly, made sure there's no fibers on it, no hairs, no dirt. Super clean. We're going to start with this cylinder back here, so we just want to put that pin at bottom dead center and get it directly aligned with that cylinder. Doesn't have to be perfect, but at least in the general direction there. Now we're going to flip the engine upside down and clean that cylinder. Now we're going to take our WD-40 and clean out the cylinder. WD-40 is great to use on cylinders because it's a little bit oily, so it's going to lubricate the cylinder a little bit and get the piston ready for installation. But also WD-40 is great on any kind of machine surfaces because it gets rid of all the moisture and it leaves a lubricant behind to keep it from rusting. And surface rust will build up very quickly on anything that is machined. And you're going to wipe these several times to make sure that there's nothing left in it. This rag should come out perfectly clean with no dirt on it. So then you pull that rag out and there's nothing left on it. That's when you're done. There's still a little bit on there. We're just going to keep on going. And I'm doing this cylinder opposed to the other side because I'm going to knock out both of these cylinders at the same time so that I can assemble both pistons, get both rods ready, get both bearings ready, and be able to do them back to back. So that's really clean coming out of there. So that cylinder's good. I'm going to go move to the other one. Dirty. This isn't the first time I've cleaned these since I got this back from the machine shop either. That's super clean coming out of there, but I'm going to wipe it one more time. That's what you're looking for. Okay, now that our cylinder and our rod pin is super clean and ready for the piston to go in, we're going to get the piston ready to go. Okay, first we want to separate our cap from our rod. Now you're supposed to use a rod vise to do this, but I'm just putting a towel in there and not clamping it very hard at all. Luckily these bolts aren't very tight, but it's good to ask your machine shop to just loosen these bolts up for you. I don't know why my machine shop decided to torque these. I guess they assumed I had a rod vise, but I sure don't. So I wouldn't advise you to use a vise like this. You should have a vise with soft jaws on it or an aluminum vise. But those aren't very tight in there, so I'm not worried about that hurting anything. Just make sure that you're clamping it by the cap, not by the rod itself on this beam, or else you could end up bending it. And these caps are sometimes on here really tight. So what I was doing is just clamping it in the vise and then just pulling up on it. You have to wiggle it. Next, I'm going to clean both surfaces here thoroughly, as you can tell. I'm gonna clean the piston. Clean out all those grooves where the rings are gonna go. Super important that there's nothing in there. I'm gonna use air to blow these off. I'll do the same for my cap. Be mindful of where you're blowing all that air, because if I was doing it this way, I'd be picking up dirt off the ground and blowing it toward my engine. So just want to minimize that as much as possible. So now that our piston assembly and our caps are clean, we're going to come in and assemble the bearings and the rings. So I'm going to start with the bearings. Since those machine surfaces are nice and clean, I don't want any dirt to get in there. So I'm going to unbox one of my sets of bearings here. I'm going to inspect it, make sure that there's no deep scratches or grooves or imperfections. These bearings have a coating on them that's going to wear off once I start the engine up. So teeny little marks on them isn't going to hurt anything. But basically, I want to keep the back of these really dry and clean. So I'm going to wipe off the back. Match up the tang with the tang on the rod. Go ahead and push those in. Make sure that that is flush on the top. There is no edge. You can feel it with your fingernail. Do the same thing with the cap. Now that our bearings are installed, they're ready to go. We're going to put the rings on. The oil rings, they have a very high tolerance being able to have the gap. They're a little bit bigger gaps. But with these compression rings, it's super important that the gap is correct. I'll show you how to gap these right now. So we're going to take our lower compression ring, or our second compression ring, and make sure that it's clean. Make sure there's no hairs or anything on it. They come out of the box with a little oil on them. It's like a rust prevention. These are cast iron rings. We're going to install it here into the cylinder. Kind of hard to do with one hand. I'll turn it this way. We'll turn it like that. And then we use our piston to square the ring into the cylinder. You just want it about an inch down. I like to use those piston skirts as a way to make sure that the piston is square in there. And then the rule here is 3.5 thousandths of an inch for every inch of cylinder bore. So we have 4.02 inch bores here. So we want somewhere between, like, what is it, like 14 thousandths to somewhere between 14 thousandths and 22 thousandths of an inch will be fine. They actually pre-gapped my rings and told me that the top ones would be 22 thousandths of an inch and the second one would be 23 thousandths of an inch. But I'm going to double check that. It's always good to have the machine shop pre-gap your rings for you. It saves you time and money, because if the gaps are too small, you're going to have to open them up using a ring end gap filing tool. And you're basically just going to file away at that ring until the gap is bigger. And then you have to use a machinist file to deburr the edges. And then you're just spending more money on tools. You're spending more time trying to gap all these rings when you could have just had your machine shop do it. But even still, I'm going to check their work with this cheap, simple feeler gauge. And they were pretty right about that, about 22 thousandths of an inch. I'm going to try the 23 and see if I can get in there, because it's just definitely at the biggest clearance that I'd want. I can't fit my 23 in there. So yeah, they were right on that 22 thousandths of an inch on that second ring. So that ring's going to be good to be installed. And then I'll check the top ring as well. And that is right on the money at 22 thousandths. So we're definitely on the bigger side of the gap there, but it's going to be just fine for our application. I actually would love to be able to run nitrous on this car one day. And so it's good that these gaps are a little bit big, because that will allow me to run like a 150 shot. So those rings are good. Let's install them on the piston. So we're going to start with our oil rings. First, you start with this expander ring. And then that gap where it butts up next to each other, you want that gap to be facing up this way. So not down how it was, but up like that. We're gonna put them on here. Always follow your ring manufacturer to see how they want the orientation. But for LT1s, I found on Shoebox, there's a specific orientation for LT1s. So I'll show you the stock orientation. So with the pistons front facing that way, on the right side of the engine, we're gonna put that end gap here. See, it's kind of hard to see on camera, but there's the gap. So put it right there on that center line. And then our two oil scraper rings are gonna be on this side of the piston, on the left side, about here and here. So we're just gonna separate those apart a little bit. And all of your rings, if they have a top or a bottom of the ring, or if there's like a chamfered edge, it's gonna be marked with either a dot or it'll say top, something like that, to let you know which way is the top. With these oil scraper rings, they don't say anything on them. They don't actually matter which way they go. So you start by sliding in that bottom edge of the ring. It's a little bit tricky. And then you just spiral this ring around the piston. Follow it along to make sure that it's not getting caught in anything. See, because it'll get caught on that butted up edge right there. And then right when your ring gets toward the end there, you want to pick up this corner so it doesn't scratch your piston coming down. And guide it up over that expansion ring. Just like that. We'll take our upper oil rail scraper. And then we'll put it over here on this side. On the top. Just like that. Guide that piston ring around. Guide it down over the piston so it doesn't scratch it. Oop, my glove got caught there. Make sure it didn't get in there or anything. You don't want any FM on your pistons either. Okay, the second oil ring, in the box it will specify which one's the second ring, which one's the top ring. This is my second ring, and as you can see, hopefully, there's a dot on that ring right there. That dot faces up per the manufacturer's spec. Always follow manufacturer's spec. The second compression ring, the gap is going to be on the same side here as those oil rail gaps right there and right there. And I'm going to put it right here in the middle. Now it's super important that you don't rotate these rings around the piston, or it could actually crack these rings. They're super brittle. They're made of cast iron. So you have to use one of these piston ring expander tools. Just go ahead and set that in there. Sorry if you can't see that. Just like that. You want to try to avoid having it snap out like it just did on me, but that'll be okay. And then these top compression rings are not marked. They do not specify up or down. There's not a chamfered edge on them. So I can flip these either way. And then I'm going to put this 180 degrees out from that second compression ring. I like to get the back edge in there. Oh, I slipped out again there. Just want to be really careful with that so you don't scratch your piston. I like to get the back of the ring in there. Just like that, and pull it forward and then slowly release it in. Just like that. Okay, now our pistons are ready to go in. Just gonna double check all the rings. If your oil scraper ring assembly is in right, you should be able to spin all three of those rings as one piece. They should not rotate independently. So everything's in good place. Just gonna rotate the engine so that cylinder's up. It's gonna make it easier to guide that rod down in there without it hitting any of the cylinder walls. Put some clean gloves on. Get some oil in the cylinders. This kind of been an easy way to do it. Just kind of spray my hand and rub the oil in there. You can use just 5-weight oil, something you're going to use to start up the engine with when you're ready to run it. Now you want to put some assembly lube on your bearing. Just give it one more quick look over. Make sure that there's nothing on it. Get some assembly lube in there. You also want to oil your piston ring compressor. I already did from the other pistons, so I'm ready to go. Just go ahead and guide your piston down into this. It's kind of awkward to hold it. Double check your ring orientation before you do the final install. Make sure that nothing got moved around. Everything looks good here. Check the orientation of your piston one more time. Make sure that the arrow's facing forward. The chamfer on that rod bearing is facing toward the outside of the block or toward the headers. Let's get that piston down in there. Just do it so that the skirts stick out a little bit. That way you have something to put into the cylinder. And then drop it down nice and carefully. Just like that. Now before you drive that piston down in, it's super important to put a rod journal protector on there, because if you drive those bolts down in there or those studs and you nick that journal on the crankshaft, it's possible you're going to ruin your crankshaft. So get your journal protector tool, put a little bit of oil on the insides here, and then just guide it up over that journal on the rod. Put it on those studs up there. Hold the piston just like that. And then just take a rubber mallet and then just guide that rod down on there with one hand while you drive the piston down in. And as much as possible, you want to try to get this down in one motion. Sometimes you got to hit it 2 or 3 times, but the less the better. And just make sure that that ring is on the block flush all the way around, because if one of your rings pops out in that gap right there and you hit it again, you're going to crack that ring. So here we go. Just like that. Take your compressor off and then just guide it down the rest of the way. All the way until the rod meets the crank. And then pull the journal protector off. Flip the engine over. We'll give this side of the rod one more look over. Make sure that nothing fell on it. Make sure it's still super clean. Looks good. Check your bearing one more time. Make sure that nothing fell on it. Make sure it's still super clean. We'll get a little bit of assembly lube. And then you want to make sure that the dots on your cap is on the same side as the dots on the connecting rod. And if you put these rods on right, the dots should always be facing toward the crankshaft, not toward the other connecting rod. And then just push those on as far as they'll go. You might have to give it a tap with a hammer. And then ARP requires you to use this fastener assembly lube to achieve the proper torque. So you just put a little bit, if you have ARP studs, which hopefully you do, because you have a 2-bolt main. And if you're trying to get a lot of power out of this or rev it higher, you should definitely have ARP. And then just get these nuts started on here. So that's how you install one of your rods. And now I can final torque these caps to 55 foot-pounds. And then next we want to check our, what's called your rod end play. So your rods have this little bit of clearance to move back and forth. And the LT1 spec is anywhere from 6 to 14 thousandths of an inch. So we'll start at 6 and see if we can get that in there. Just gonna push them both to one side. And that one fits in there. And as long as it's in between that 6 and 14 thousandths of an inch, then you're in spec. You can also check it in the middle here. Once you have all your pistons in, just do a quick check to make sure that all of them are facing forwards. Make sure that the crankshaft rotates smoothly, and we're ready to move on to the next step.